SwayamPrabha. Digital India. Educated India.
I'm very glad to be here at IIT Bombay, particularly sharing some of the work which we are actually trying to do at IIT Delhi. I am associated with a lab which is called as Assistech Lab. So Assistech comes from assistive technologies. Assistive technologies is a very broad word. If you want to take a more generic definition, many of us in the classroom use assistive technology, which many of us are wearing. So that's also an assistive technology. But I think we are basically working on assistive technologies for the visually challenged. In fact, what happened is we started looking at educational needs of the blind. Then we found that before you actually address the education, you need to address their mobility needs. If you are not mobile, then I think the education also suffers. So then we went back and started looking at the mobility aspects, and then now we went back and looking at the education aspects. So that is a focus, and it's a very different lab. Usually what happens is in institutes such as IITs, you will have labs which are primarily either called as a teaching labs or research labs, but we call it more as an innovation lab, because here we look at the grand challenges which are facing society in a particular domain and try to build a solution which is like end to end. In other words, our journey is complete when we know that the design and technologies on which we are working has ultimately made an impact. So we had almost like 5 or 6 products which are now in the market. I thought today we'll discuss about one of the products which was very early products which we worked on. And let me also tell you, most of the work which is done as a part of this is also part of an interdisciplinary team. A lot of technology students working with design students. Innovation truly actually requires a marriage of multiple disciplines. Technology and design are major, but sometimes you also need management, social science, arts, policy, and it's actually a very good marriage of these. So one of the product which I wanted to discuss is called as a Smartcane. All of you are familiar with the white cane which is used by the people with visual impairment, and this is like a really a true companion for somebody who is blind. Once you are outside, imagine that for a moment you are taken away, like somebody takes a white cane from a visually blind person who is outdoors. The person actually cannot move because you really do not know what the, let's say, the environment would look like, because this is like a sensing instruments to know where the environment is, and you get to know a lot of things, whether you are walking on a hard surface or a muddy surface, many other things. But issue which comes with the white cane is that situations such as this cannot be handled by a white cane. It's a wonderful assistive technology if you want to know the obstacles which are knee below, but anything knee to head height, people only come to know through collisions. And this is not just India, it's universal, it's worldwide, whether you go to US, Canada or Germany. But only difference which we have is that in many of the countries, particularly Europe and US, the environments are very structured. So the laws are pretty strict. So what happens is it is very unlikely that you will have a lot of environments and obstacles which will have upper body injuries when you are actually moving with a white cane. But 90% of the world still is very unstructured, and where you will see a lot of obstacles such as this. So this was one of the problem which was posed to us. Can we address this particular problem? Can technology and design can address this particular problem? Was one of them. Rohan was one of the undergraduate students who was asked to take this as a project. And he not only did a good job, but I think he spent much more time. He went to Oxford to do PhD as a Rhodes Scholar. While he was at a Rhodes Scholar, he continued to work on the project. After his PhD, he came back and again worked on the same product for 2 years before going to MIT for his postdoctoral. Now he is back as a faculty at IIT Delhi.
A student project, along with the Professor Rao, Professor Balakrishnan, we started looking at how technologies can be and devices can be developed to aid mobility for persons with visual impairment. In fact, we had a chance meeting at the National Association for the Blind, and it was Mr. Dibendra Manocha at National Association for the Blind who highlighted the fact that mobility is absolutely fundamental for a visually impaired person.
So one of the solutions which people can think of is to use some kind of a sensor, either infrared or ultrasonics or a laser, to detect the obstacles and then convey the presence of an obstacle in the form of some output. So what should be a typical output for such a thing? Suppose, let's say, a person encounters, how should this be conveyed to a user? That's where probably a little research really helps. Some of the devices which were built with auditory output did not work for a few reasons. One reason is that there is an obstacle, but you are not able to hear or you are not able to convey this particular information. It's a too risky to have. The second thing is the people who are disabled would not like to actually declare that they are visually impaired. It's like if you have a device which is continuously, let's say, giving an audio output, you are declaring that here am I, a blind person trying to walk and kind of a thing. And people don't like that. And these days, vibratory output is a very well known. We all use cell phone vibrators, etc. It's a pretty one. So that was the kind of a solution which was initially used. This sensor such that it could cover knee to head height, all the range of obstacles, and one could actually go. So this was one of the first prototype which is built. When educational institutes build their first prototype, it's always like a proof of principle. It's not even a proof of concept, whether the concept is going to work or kind of a thing. And you take it to a people, like here is a blind person who is actually trying to test it. And what happens is, this was given to a students who are in computer science initially. They could address all the sensor programming issues very well. But I think they probably didn't do a good job with other aspects of engineering, like material, mechanical, in terms of having a right center of gravity. If you see a product such as this, you will always have a small torque which is acting, which will always take the sensor in the other direction. And these things are generally not taken care. So this is like a first proof of principle. And the users mentioned a list of some 20 to 30 problems with the prototype and why it cannot be used kind of a thing. Then you come back and probably take care of some of the user aspects. Now you bring few mechanical engineers into your team and let computer science and mechanical engineering students work together and build another prototype and take it to people. Now you have the number of problems which came is doubled. Now, not only those problems, some of them remain, which did not solve, but now users have many more additional problems. So what generally happens, this is how most of the projects actually get done in colleges, correct? Usually not many of them go to user. If at all it go to user, it's something which probably may not meet their requirements. So then we thought there is something wrong with this type of innovation process. This is okay for learning purpose, for an academic purpose, but if you really want to make an impact, then you need to take care of every small aspect what user would need. And that is where sometimes the design and design education and design thinking helps in a much better way to do that. So what was done is that if you actually look at process of innovation, where you start from one end to another, you have a lot of these pitfalls. So one of the things which was not done is, before I start addressing any problem or finding a solution, did I do enough research even to understand this particular problem completely? In other words, earlier attempts were more of, let's say, somebody gave a problem and you jumped onto solution and attempted it. You know that it's not going to work. Can there be a more systematic process to innovation? The answer is certainly yes. And it says that we have to spend much more time just understanding the problem even before you go to a solution. And it also reminds me of a saying once Einstein said, that if I have about an hour to solve a problem, I would spend 55 minutes thinking about the problem and 5 minutes to the solution. And probably it was not very well understood when he said, but it's becoming more relevant in today's world kind of. Before you even start attempting such problems and solution, you first need to do a lot of research into certain aspects. First thing is understanding the disability. You are suddenly asked to do a product or a solution in the space of disability where you have not really studied the disability. You didn't understand what disability is. When you actually look at the scenario such as India, whenever you see a disabled person, most of the people would look at a disabled person more from the sympathy or a charity point of view. And I think once you start interacting with them, you know that that is not what they need. What they need is an empowerment. They want to socially integrate with persons without blindness and do all those things which others are not able to do. Now this comes only when you jump and start understanding, interacting with the users, immerse in those environments, shadow the people to their, let's say, daily activities. Then you start understanding many things. And that's very essential if you really want to build a solutions which can make an impact. If I just want to do it for academic purpose, probably it's still okay. But if I want an impact, this is an important aspect. Similarly, what are the assistive technology and understanding users, user environments? We generally suggest that if we are trying to do a product or a solution in a space such as this, it's more of a social innovation. Immersion is a very, very important tool. That means how many hours, days and weeks I spend in the environments or put myself in the shoes of the user is extremely important. If I'm not doing it, there are certain things, or again, when I go back to the users, they'll give me a much bigger list saying why it's not going to work. And also, it's not always true that users are customers. Customers could be very different from users, correct? I think we all use products where we are users like Facebook, but we are not the customers. Someone else is paying for if I'm trying to use, and same is here. In many cases, assistive technologies is actually bought by the government and sometimes given to the people with disabilities. So they are not the direct users, but they are still the customers who will buy products and solutions if available in the market. So understanding all these aspects, even it happens with stakeholders too, and it happens in multiple situations, not only this. Some of our students were actually working on a medical device, and they actually found that patients really need this device. They spent almost an year and took this device to the doctor. Doctor said this device is not needed. We are not going to prescribe. Now, if you don't take a doctor into your scheme of things or make them a stakeholder, you may come up with a wonderful product, but it doesn't go through because you haven't consulted a doctor when you started this particular project. So the idea is that you don't want to leave out any stakeholder who is a part in this whole game. That's a very important aspect. And one should also look at how is the problem being addressed currently. What are the problems is another important aspect. And there are a whole lot of other things. Just to give an example, suppose let's say if I want to buy a thermometer, where do I go and buy? Medical shop. If I want to buy a white cane, where do I go? Huh? Amazon. Is it available? Sure. Okay. Other assistive technologies?
Doctor's prescription.
Doctor's prescription. But disability is not, all disabilities are related to health aspects, correct? For example, let's say if I need a new gaming console, doctor is not going to prescribe, correct? And I want something which is more accessible gaming console. So where do I get it? So the normal e-commerce marketplaces do have some aspects of this thing, but they still don't house many of the assistive technologies. And second aspect is there is an extremely small percentage of people who need them use the e-commerce websites also. Because most of the people who are with disability come from an extreme socio-economically weaker conditions. And usually e-commerce is not a very big thing. Even if I put it, it's not going to sell. We have our product on e-commerce. Probably the number of units which we would have sold is extremely small because it's there on Snapdeal. It's there on other e-commerce marketplaces, but it doesn't sell because for this community, probably that's not the best aspect. So how do I figure out, like how do I reach out to, let's say, 5 million blind people in India once I have a product? I also need to figure out those aspects, and probably this interaction and immersion with the user is going to tell me these are probably the routes through which I can actually reach out to people. In other words, what we're actually trying to say is that if you ask me to define innovation, I'll say innovation is something where if there are 200 reasons because of which your product or solution is going to fail, you may address 199, but still it's a failure. Because you left out that one aspect which became a reason for failure. But how do I know that these are the reasons for failure? Understanding all those reasons and eliminating them is the process of an innovation. Somebody can say that I have designs, but there are no takers. Very accepted, it's very much acceptable. If somebody says I have innovations, but there are no takers, it looks little odd. Why it looks little odd is if there is some problem because of which innovation is not making an impact, that particular aspect has not been addressed, and hence it's still an incomplete innovation. So innovation is something where you don't want to leave anything to chances, etc. Whereas I can still say that, okay, I have wonderful designs, but there are no takers. It's possible. Then what happened with this particular product is students and the team went back and said, okay, let's go back to the research and do a much more understanding. And almost 6 months were just spent with the users, end users, understanding, going to blind schools, going to places where the blind community actually meets, listening to them and trying to understand this aspect. And this investment in research is extremely important not only for product, but for the entire life cycle till you make an impact. I'll just give an example. Like if you ask, as I said, most of these people come from extreme socio-economic condition. And suppose, let's say if I price my product 3,000 rupees, and if you ask them, are you willing to buy for a 3,000 rupees, most of them would say no. Because probably having a savings of a 3,000 is not thinkable for many of the people. Even there are large percentage of people who can't afford to buy a white cane which is 200 rupees. And you are actually saying, here I have a product, can you buy for a 3,000? But when you interact with these people, you come to know that the people who can't afford 3,000 rupees can spend 20 rupees per month. This research and this information gives me that I can still sell. Probably I'm going to come up with a very different business model, having understood the people. It may be an EMI, or it may be something which may be a rental aspects, and it's still going to work kind of a thing. If I don't do this research, I can't even come up with a better business model subsequently also. So it's not only helps to just find the product and solution, it's also helping you to see how can I reach out to people. So this research we found that is an extremely important, and I think this research is very well done by the designers. Usually we have seen that the people who are very close to user and who co-create solution with the users are the best people to do that kind of thing.
I mean, did anything come up in the research where people said that maybe cane is not the best option?
You mean to the Smartcane is not the best option for this problem?
No, I mean, just a cane. I mean, we're making a smart cane out of the cane. So out of the research, did anything come up which showed that a different form would maybe
like a belt or a helmet or something which can do the same thing.
like a necklace which has sensors.
Okay. Yeah. So I think this is a very important question. Can we have like necklace or a helmet, or that's where it actually answers this particular question. How is the problem which is presently being addressed? There are people who have built similar things, like there is a product which is like a necklace, there is a product which is like a goggle. So you have the sensors which are built in it. Somebody made a torch, ultrasonic torch like this, which you can actually do this. Somebody has put it in a belt and shoes. So people have used all these options and all of them have kind of terribly failed. Why did these solutions fail? Is that they underestimated the importance and the power of white cane. They try to replace the white cane and try to come up with an alternative solution for that. Imagine there is an ultrasonic torch instead of this thing. It can still, there are few problems. First thing is your knee and below is still done by the white cane. So now if you remove that, when I am walking, there may be a serious drop off. How do I come to know that there is a serious drop off? And it's extremely risky to remove a white cane in those situations. And other thing is white cane gives you a lot of information. If you see people who use white cane, they sometimes probably also, you can see them waving. That is basically trying to understand the environment. And now what happens is if I have an ultrasonic torch, then there is an extra thing that I scan it in such a manner that I am not going to miss anything. If I miss, then it's going to be a risk kind of. Those aspects become an extremely important, that anything which you try to replace generally have not worked, and they have closed, people have tried and given up. So this important that people have tried and given up for this reason becomes an extremely important for me not to try and probably try something which is a new aspect. So what we found is that often we give a lot of importance to understanding the user and user environments, but large number of innovations which we have now done in assistive and medical, we found that stakeholders, all the stakeholders are extremely important. For example, somebody who is called as a healthcare professional is a person who trains visually challenged people on mobility. So one of the versions of the product which we built, the person came and said, your product looks good, but it is extremely difficult to train people on. Since we did not consult those people from the training perspective, they kind of rejected our product in one of the versions. So then we realized why each of these stakeholders is extremely important and where failure is likely to happen. Let me give a very interesting example from Mumbai for the stakeholders. We were working on another product and solution where a visually challenged person can board a bus independently without sighted assistant. So there is a small handheld device which helps me to know two things. First thing is ki which number bus has come. And second thing is where is the entrance of the bus so that I can actually walk and board independently. Now, when we did this particular product, we thought we did not consult many of the stakeholders. And when we came to deploy this particular thing in Bombay, in one of the depots called Back Bay Depot, so we wanted to put it on 25 buses. Then we discussed, we found that there are at least about a dozen stakeholders in this whole process, starting from general manager, who heads like best, to the conductor, the driver, the depot manager. Unless you take all of them on board, they are not going to let your innovation go ahead. Then you need to convince the value which it brings before you can actually take them onto a board aspect. So these are like the real life solutions where you go through a process and realize how important this stakeholder was and how ignoring this stakeholder has costed me things which probably would not have gone. And then when you do a research, you not only come to know it's not just the tree branches which are there are dozens of other obstacles like standing trucks to protruding air conditioners, all require a visually challenged person to negotiate, and this is also probably needed for most of others because you're not going to build a solution for one obstacle, it's for all types of obstacles kind of. When you give one of the prototypes to try to the people, you also come to know that you expect people to hold the Smartcane or a white cane in a particular manner, but then you come and do a research, you see that people hold in 4 or 5 different ways the product. And how they hold is extremely important for your product and solution to work. Because why it's important is the vibrations which are felt is important to know what are the obstacles in your knee to head height. But whatever is the information which you are getting from the white cane, like surface texture, etc., that should not be lost because of the vibration. The moment you, like one type of output dominates, you again fall into a risk and you have to rework kind of a thing. And for that, you need to know how the people are going to grip. Depending on the grip, your sensor position is changing. You know whether it is actually pointing out to head or below head or above head is also, all that information becomes extremely important. And all these things generally comes when you do more user interaction. Technology sometimes happens quickly, but at least the first cut of technology, but the real problems are very different. What we did is we also bought all the existing products in the market, particularly international market, and gave it to users for 1 week and said, try and give the feedback about the existing products. This is like an ultrasonic torch, which I mentioned. And people said, this is something which they would never like to use. Here is another one where the vibrations are felt in your head. And people said, many of them did not use not more than 3 minutes. They say, I don't want my vibrations in the head. It's very awkward kind of a thing. The feedback which came for this is saying I have been used to using a white cane with a particular grip for last 15 years. Now you are asking me to change my habit. And people are extremely reluctant to change their habits just because you are now trying to design a new product. People will do that only when the value addition is extremely high. You think of any innovation where you bring a very small value and ask people to change their behavior and habits. It's not going to happen. Okay. So there are various feedback, but they also give the good points in these. So now as a designer and as a technology person, I know what are the choices which I can make in terms of sensors, in terms of form, in terms of this thing, so that I bring my own USP where probably I'm going to do better than the existing one. Why these existing one did not reach the people is that they typically cost anywhere from $600, $700 to $1,500. And you are actually trying to sell it to people who have a difficulty in, many of them, buying a cane of 200 rupees. So now that's a bigger challenge. Even though these are in the market for quite some time, some of them, of course, now are closed, but still they are not able to reach out to the 90% of the world population. What we found is that it's extremely important to go back and apply the design principles. So we always say about divergent, convergent thinking, which is there. So we thought, let's do both for the problem as well as for the solution, which is there. Then it went through a lot of iterations. Okay, and I think the one common rule in all the innovation is fail, but fail fast. And probably one iteration is not going to give you all the inputs and take care of all the user requirements in one. You can take care of most of them, but again, you have to come back to your prototyping and redo and probably rebuild the prototype solutions in order to do kind of a thing which is there. And it went through a multiple prototype. The version which was launched in the market was the 12th prototype. Some of them are probably not the functional prototype. They may be like look-alike, work-alike prototypes. Some of them are functional prototypes, but altogether we had to do about a dozen prototypes before we could say that here is something which people are going to accept. And now I am very confident that during these prototyping sessions, I have addressed all aspects, or at least the most of the aspects which user would require.
Was the user's height considered when making the sensor for it? Because, I mean, does it vibrate only when I'm about to hit something, or if something is above in general?
So I think this is a very good question, in the sense that what should be the detection range, yes, which you are saying. So typically one is of course knee to head height. So usually you take a certain this thing. For example, we took typically 6 feet 2 inches as the height, okay, which is the height which it should cover. You can also broaden a little bit. There are methods to do that. The second thing is, it's not only important to cover the vertical one, you should be able to cover the horizontal one also. So how much horizontal? What would be your answer, suppose if I want to cover? Huh? Around 4 feet.
Widest person.
Huh?
Take widest person and then add 1.5 feet on both sides.
But that's like not 4 feet. That would be much smaller than that, correct?
4 feet, and that's the size of the bed.
Okay, so the problem with 4 feet is, let's say I am inside a room and I have to exit from this particular room, and if I have, let's say, a door which is less than, let's say, 2 feet, then I'll never be able to detect that there is a gap through which I can actually go through. So you need to keep a narrow, as he said, you take the width and add a plus or minus, and that's a probably you should be able to do that. The moment I make it this thing, my obstacle detection increases, good, but pathfinding becomes very difficult. You know, if you know ultrasonic ranging, it's basically a conical, correct, which is there. So that means the more the distance, it's covering more of a diameter kind of a thing. So it can detect anything up to 3 meters. 3 meters is the range. Now 3 meters also, when you have a range, you don't want to have just telling that there is an obstacle at 3 meter and there may be something which is just very close to you. In both the cases, you are saying an obstacle doesn't help you. So what one needs to do is that you need vibratory patterns which in some way are also proportional to your distance. So when you are at 3 meters, you are walking and suddenly at 3 meters you encounter, you have one type of a vibratory pattern, it only alerts you, it doesn't stop you. Okay. And what happens is when I am using a white cane, when I am still, let's say, waving it to find an obstacle, which I still do, then I know that in one particular direction there is no beep, there is no vibration, in another direction there is, that basically gives a clue that probably right side there is no obstacle and I can still clear it off. So it also requires a little bit training, and users who have to use are given a 2-hour training in orientation to understand this, and we found that that is enough for people to be independent. But you keep learning over a period of time, but after like a few weeks you are probably as good as using your white cane facility. It's basically like when we start driving car for the first time, we know how we make our decisions, and once, let's say, you have been driving for 3 years or 4 years, your maturity levels are very different. Same thing happens in the same mobility here too. But that, now how do I restrict, let's say, the width to be a smaller and vertical to be higher is that you can do it through programming. If you know how to program for the sensor and sensor information, you can always actually do this particular aspect.
How did you know when to stop iterating?
So what happens is every time you go to a user, you always have a big checklist. So from this checklist, first thing which you are going to decide is what is that you are going to address and what is that you are not going to address. When we took this particular product, people wanted a few more things on this which we did not address. Somebody said, can your Smartcane can also detect, for example, the dogs. In one of the campuses, there have been too many dog bites of the visually challenged people. Can there be a sensor to know that there is an animal or a dog? We said that's not we are going. If I want to do that, then probably I need a slightly different technology, different cost, and a different market. So that decision has to be made when you actually do that. Another person said, suppose, let's say, I keep my Smartcane somewhere in the room and I don't know where it is. How do I know? Can there be another sensor which can, like an object detector? Okay, or through my mobile phone, I should be able to know you have another sensor which beeps so that I can use the audio clues to find out. We said we are not going to do that. If you look at their wish list, it's always much more. But I think somewhere you need to say, once you have decided that these are going to be specifications, at some stage you need to say, this is going to be a specifications of my product. And once you know that those have been addressed, tested, that's a time when it's also like a gut feeling. I don't think there is any rule or a green light or a red light which says, oh, now it's a green light, stop the iterations going to be. And it can always happen that even after you launch a product in the market, you may still have a couple of things which you may have to change it. And sometimes for a very different reasons. I'll just give an example. When we took this particular product, we launched this particular product, most of them asked what is the color of this particular product. Now, probably you did not think color is something which is very important, but color was extremely important for them. Like that's a mistake which we do, कि somebody who can't see, they don't have a color choices, etc. That's not true. Somebody, in fact, very arrogantly asked also, how does the color matter to you? I think that's probably one of the biggest mistake the person has committed in asking this question. And everybody was angry. They also answered little arrogantly. They said, when you buy a shirt, like I think this thing is, it's not just that you like it. You also want others to like it. And why are you denying that opportunity for us? So the aspirations is an extremely important aspect. And unless we do a good user immersion, we may ignore the aspirational aspects and end up with the products which may fail because it did not meet the aspirations. So it's a very balanced kind of a thing. And it's also possible that if somebody does an urgency and doesn't do enough prototypes and goes to market, product may be a failure. And somebody may probably do more iterations, but then there is also a risk of probably not being the first to market. So it's a very balanced view. But if you think that the prototypes which you're doing is going to add a lot of value, then I think it's certainly. I think there is a very interesting paper which you should read. It's called Second Paradox of Toyota. So when the entire world was reducing the number of prototypes to capture the market, Toyota went and did more prototypes and came up with a product which kind of captured the major US market. In fact, people thought in a world when there is a lot of it is happening digitally, why did Toyota go and do a lot of physical prototyping and spend more money and time and delayed their launch? But I think ultimately the launch proved that it is something. So it may not be the case always, but we need to make a very judicial choice when to stop the prototype. And sometimes prototyping may be for just testing one particular feature of the product. So that could be done very quickly. You don't have to build another functional prototype.
At what time does the market come in ideation? Like, do you consider that it should be within 500, so I'm not going to ideate in this direction, or something like that?
The market considerations actually come earlier they can come, the better you would be placed, kind of a thing. That's what I think. If you have seen the slide which is pitfalls of an innovation, you have there is a research to design, design to prototype, prototype to scale, and scale to market. What happens is, if I look at this process as a very sequential, then it's quite possible that at somewhere in the third pitfall, I realize that my design is not going to go through the third pitfall. Then you have to go back and redo this particular aspect. But if you had a little, let's say, an idea how the market is going to look like, probably your solution will take a very different path and it's more likely to succeed, or you end up doing less number of iterations. It may still succeed, but you end up doing more prototyping, more iterations.